In this video, we're going to talk about how to convert from one unit into another. We're going to talk about units associated with distance, mass or weight, volume and capacity, time, as well as units in the metric system. We're going to cover that as well. So let's begin by taking some notes. Hopefully you have a sheet of paper with you, and you may want to write down a few things. So let's begin with units associated with distance. You need to know that there's 12 inches in a foot. 3 feet is equal to 1 yard. 1 inch is equivalent to 2.54 centimeters. 1 kilometer is equivalent to 1,000 meters. And these are some very common conversion factors that you might come across when dealing with unit conversion problems. Now there's more. 1 meter is equal to 100 centimeters. 1 mile is equal to 1.609 kilometers. And 1 mile is also equal to 5,280 feet. So those are some conversion factors that you want to know when dealing with distance or length. Now let's talk about conversion factors associated with mass or weight. So here's the first common one that you'll see in chemistry and even in physics sometimes. 1 kilogram is equal to 1,000 grams. 1 kilogram is also equivalent to 2.2 pounds. Kilogram is a unit of mass, but pounds is typically a unit of weight. Even though you can convert from one to the other, they're not exactly the same. And mass is really a quantity of matter, whereas weight is a force. But you can convert from one to another. Now, 1 pound is equal to 16 ounces. 1 ton is equal to 2,000 pounds. And then there's a metric ton. This is not exactly the same as a regular ton, but a metric ton is equivalent to 1,000 kilograms. It's also equal to approximately 2,200 pounds. And for those of you who want a more exact value, it's really 2,204 pounds. 1 kilogram is 2.204 pounds, but you could use 2.2 pounds as a rounded value. So those are some common conversion factors that you want to be familiar when dealing with mass or weight. Now let's move on to the next topic, that is conversion factors for volume or capacity. One liter is equal to 1,000 milliliters. 1 milliliter is equal to 1 cubic centimeter. And a cubic meter is equal to 1,000 liters. 1 gallon is equal to 3.785 liters. A gallon is also equal to 4 quarts. And 1 quart is equal to 2 pints. You may not need to know that one. That's really not a common one, but sometimes you may see problems associated with it. Now let's talk about units of time. Many of you are aware of these units. So here's some common ones. 1 hour is equal to 60 minutes. And there's 60 seconds in 1 minute. There's 24 hours in a day. And there's approximately 365 days in a year. Now, if you're dealing with a leap year, which happens every 4 years, there's 366 days in a leap year. In that month, like in the month of February, there's 29 days in a leap year. But in a regular year, there's 28 days in the month of February. So keep that in mind. A typical calendar month has an average of 30 days. And 1 century is equal to 100 years. 1 millennium is equivalent to 1,000 years. Now let's go back to a leap year, which we said is 365 days. 366 days rather. Because that happens every 4 years, if you were to average that in, you get a typical year is more specifically 365.25 days. Some problems may require that you use the 0.25 days, others may not, so you need to use your judgment whether you're going to use this conversion factor or that one. Either case, the answer shouldn't be that much different regardless of the two that you choose to use. But just keep in mind that small difference. For some problems, it may be significant. Now let's talk about the metric system. You need to be able to write a conversion factor after you commit this to memory. So let's go over some things first. Tera is 10 to the 12. Giga is 10 to the 9. Mega is 10 to the 6. And then kilo is 10 to the 3. Hecto, 10 to the 2. And then deca is 10 to the 1. And then you have your base unit. And then below that, deci is 10 to the minus 1. And then centi, 10 to the minus 2. Milli, 10 to the minus 3. Micro, that's 10 to the minus 6. Nano is 10 to the minus 9. And pico is 10 to the minus 12. There are some other ones, but typically you won't need to know the other ones that are outside of this range. If you do, just look them up and you may want to write them down. There's some other ones like atto or femto, and I'll leave it to you to review that. But with this information, you need to be able to write a conversion factor. So let's say if we want to write a conversion factor between meters and kilometers. So it's going to be 1 kilometer is equal to 1 times 10 to the 3rd meters. So here's how you could set up the conversion factors. Always put a 1 next to the side of the equation that has the prefix, such as kilo, tera, giga, mega, or micro. And then place the multiplier near the base unit, meters, seconds, watts, whatever it may be. So let me give you some examples. 1 gigawatt is equal to 1 times 10 to the 9 watts. Let me remove this. Hopefully you wrote that down. A megajoule is equal to 1 times 10 to the 6 joules. 1 centimeter, centi is 10 to the minus 2, so 1 centimeter is going to be 1 times 10 to the minus 2 meters. A nanosecond, nano is 10 to the minus 9, so it's going to be 1 times 10 to the minus 9 seconds. A micrometer is 1 times 10 to the minus 6 meters. So once you commit this to memory, it's going to be very easy for you to write the conversion factor, which will make it easier to solve problems associated with converting units with the metric system. So make sure you write this down. So let's start with some simple problems. Let's say we wish to convert 4 feet into inches. How can we do so? Well, this is a one-step conversion. We need to write the conversion factor that helps us to go from feet to inches. So if you recall, it is 1 foot is equal to 12 inches. This is our conversion factor. So that's the first thing you want to do. Identify what conversion factors will help you to do the problem. Once you do that, start with what you're given. So we're given 4 feet. We're going to put that over 1. Now, let's write another fraction. Now, we need to determine what to put in this fraction. Should we put the 12 inches on the top of the fraction or on the bottom of the fraction? In order for this to work, we need the units feet to cancel. So because it's on the top in the first fraction, we want to put feet in the bottom of the second fraction. On top of the first fraction, we're going to put inches. And then we're just going to put the numbers associated next to it. So we have a 1 next to feet and a 12 next to inches. So these units will cancel, and now we just need to do the math. So whenever you see two numbers on top, multiply by those numbers. For numbers on the bottom, you're going to divide by that number. 4 times 12 is 48. So the answer is 48 inches. 4 feet is equivalent to 48 inches. So that's how you can convert from one unit to another. Now let's try some more examples with one-step conversion problems. Go ahead and convert 350 grams into kilograms, and also convert 0.45 liters into milliliters. So feel free to pause the video and work on these examples. And then once you finish working on them, play the video to see if you have the right answer. So let's start with the first one. The first thing we need to do is identify the conversion factor between grams and kilograms. Now, we wrote this down earlier. 1 kilogram is equal to 1,000 grams. So that's our conversion factor. So using that, how can we convert 350 grams into kilograms? Feel free to work on that. So the first thing you want to do is you want to start with what you're given. That is 350 grams over 1. Then you need to decide what to put on the next fraction. So because we have the unit grams here, we want to put grams on the bottom, kilograms on top. The number associated with kilograms is 1. The number associated with grams is 1,000. So when we set it up this way, we can see that the unit grams will cancel. Now, because this number is on the bottom, we're going to divide 350 by 1,000. 350 divided by 1,000 is 0.35 kilograms. Another way in which you can conveniently divide by 1,000 is you can move the decimal 3 units to the left. So that's the answer for the first example. Now let's move on to the second example. So this is another one-step conversion problem, but here we're dealing with volume as opposed to mass. Now the first thing we need to do is we need to write the conversion factor. What is the conversion factor between liters and milliliters? As we mentioned earlier in this video, 1 liter is equal to 1,000 milliliters. So that's the conversion factor that we're going to use. Now let's start with what we're given, 0.45 liters. Since we have liters on the top, we're going to put that on the bottom, and then we're going to put the other unit, milliliters, on top. There's a 1 in front of liters, and there's 1,000 in front of milliliters. So this time, we need to multiply by 1,000 instead of dividing by 1,000, because these two numbers are on the numerator of the fractions. So 0.45 times 1,000, that's going to be 450. So whenever you multiply by 1,000, move the decimal 3 units to the right. If you divide by 1,000, you want to move the decimal 3 units to the left. Likewise, if you were to multiply by 100, you could just move the decimal 2 units to the right. If you were to divide by 100, move it 2 units to the left. So here, the unit liters cancel, and now we have our final answer, which is 450 milliliters. Now let's work on some word problems. If Karen can make 7 cakes in 3 hours, How many cakes can she make in 10 hours? Feel free to work on this example problem. So this is another one-step conversion problem. But the first thing is, what is the conversion factor and what are we trying to do here? Right now, we want to convert time into cakes, so to speak. We're given the time of 10 hours. And we want to know how many cakes can she make. Now, in order to find the answer, we need to identify the conversion factor. So now that we've identified the problem, what is the conversion factor? The conversion factor is basically, in this example, the rate in which she can make cakes. She can make 7 cakes in 3 hours. So to keep things simple, we're going to say 7 cakes is equal to 3 hours. So now let's convert. Let's start with what we're given, which is 10 hours. We're going to put that over 1. And then we're going to convert that to the number of cakes that she can make. So because we have hours on top, we're going to put hours on the bottom and then cakes on top. And then we're going to use our conversion factor here. So there's a 3 in front of hours, a 7 in front of cakes, and now we can do the math. So it's going to be 10 times 7, which is 70, divided by 3. Now let's get a calculator to convert this to a decimal. 70 divided by 3 is 23.3 repeating. So that's how many cakes she can make in 10 hours. Now let's move on to number 2. A certain map has the following scale. 1 inch is equal to 5.5 miles. If the distance between city ABC and city XYZ is 12.6 inches on a map, what is the distance in miles between the two cities? So feel free to pause the video and try that example. Now we need to identify the problem. What is it that we're trying to do here? What we want to do is, we're given the distance between the two cities, which is in inches. More specifically, inches on the map. We want to convert that into an actual distance in miles. So we want to go from inches to miles. But in order to do it right or get the right answer, we need to use the conversion factor that's given to us based on the scale that's on the map. So for this problem, not for other problems, 1 inch is equal to 5.5 miles. So this is a one-step conversion problem. So we're given 12.6 inches. We want to convert that to miles. So let's start with what we're given. And then let's use our conversion factor to complete the second fraction. So we have inches on top, we're going to put inches on the bottom. And so miles is going to go on top. There's a 1 in front of inches and a 5.5 in front of miles. So all we need to do for this problem is multiply 12.6 by 5.5. And so we're going to get 69.3 miles. So based on the scale that we're given, this is the distance in miles between the two cities. Now let's talk about how we can solve a two-step conversion problem. Let's say we want to convert from inches to yards. How can we do so? How many yards is equivalent to 180 inches? Feel free to pause the video and try that. So let's write down some conversion factors that we know. We know that there's 3 feet in a yard and there's 12 inches in a foot. So these are the 2 conversion factors that we need to go from inches to yards. So we're going to start with inches, and then we're going to convert that to feet using this conversion factor. And then once we have feet, we can convert feet to yards using this conversion factor. So let's begin. Let's start with what we're given, and that is 180 inches over 1. Next, since we have inches on top, we're going to put inches on the bottom, and then we're going to put feet on top. So using the first conversion factor, we know that there's 12 inches in a foot. So we're going to put the same numbers next to the corresponding units. So now the units inches will cancel, and here we have units of feet. So now we're going to go from feet to yards using this one. So since we see the unit feet on top, we're going to put feet on the bottom, the yards on top. There's a 1 in front of yards, a 3 in front of feet, and then we can cross out those units. So it's going to be 180 divided by 12. Let's do this one step at a time. So 180 divided by 12 is 15. And then we're going to take 15 divided by 3, which will give us 5. So the final answer is 5 yards. Try this one. Go ahead and convert 9,000 feet into kilometers. So what conversion factors do we need in order to go from feet to kilometers? First, let's make an outline of what we need to do, because this is another two-step conversion factor, or two-step conversion problem. Now we know the conversion factor that will take us from feet to miles, and then we know the one that's going to take us from miles to kilometers. So we know that we know that 1 mile is equal to 5,280 feet, and 1 mile is also equal to 1.609 kilometers. So let's start with what we're given. We're given 9,000 feet. Let's put that over 1. And let's use our first conversion factor to go from feet to miles. So 5,280 feet is equal to 1 mile. So we can cross out those 2 units. And then let's use the second conversion factor to go from miles to kilometers. 1 mile is equal to 1.609 kilometers. So remember, divide by the numbers on the bottom, multiply by the numbers on top. So it's going to be 9,000 divided by 5280, and then take that result, multiply by 1.609. So the final answer is going to be 2.7426 kilometers. So that's equal to 9,000 feet. Here's another example. Let's convert 7,500 milliliters to gallons. So what are some conversion factors that we could use here? Well, first, let's make an outline. We know the one that's going to take us from milliliters to liters, and we have one that can take us from liters to gallons. So for the first step, we could use this one. We know that 1 liter is equal to 1,000 milliliters. And for the second step, we could use the fact that 1 gallon is equal to 3.785 liters. So let's start with what we're given, and that is 7,500 milliliters over 1. So let's use the first conversion factor to go from milliliters to liters. So we're going to put 1,000 milliliters on the bottom so that these units will cancel, and then 1 liter on top. Now let's use the second conversion factor to go from liters to gallons. So we're going to put 3.785 liters on the bottom, and then 1 gallon on top. So now it's going to be 7,500 divided by 1,000, which is 7.5, and then divide that by 3.785. So the answer, it's equal to 1.98 gallons. So this is an example of converting from one unit of volume to another. So that's how you can convert from milliliters to gallons. Number 3, a book weighs 7 pounds and 12 ounces. What is the mass of the book in kilograms? So what do you think we need to do for this one? Well, we need to convert pounds and ounces to kilograms. So the book has a weight of 7 pounds and or plus 12 ounces. What we need to do is we need to convert pounds to kilograms and then ounces to kilograms and then get the sum total of that answer, and then we'll get the mass of the book in kilograms. So let's convert pounds to kilograms first. To do that, what conversion factor do we need? So if you recall, 1 kilogram is equal to 2.2 pounds. So that's the conversion factor we need for the first part. So let's start with 7 pounds over 1. And then in the next fraction, we're going to put 2.2 pounds on the bottom, 1 kilogram on top. So here we need to divide. So it's going to be 7 divided by 2.2. And so you get 3.18 repeating, but I'm going to round it to 3.182 kilograms. So that's the first part. So now let's convert ounces, 12 ounces, to kilograms. In this case, this is a two-step process. We need to go from ounces to pounds, and then we can go from pounds to kilograms. So let's start with 12 ounces. Now, what is the conversion factor between ounces and pounds? So looking at our notes, we know that 1 pound is equal to 16 ounces. So that's the conversion factor that we need to use right now. So I'm going to put 16 ounces on the bottom, 1 pound on top. So now we could cancel the unit ounces. And then we could use this conversion factor to go from pounds to kilograms. So I'm going to put 2.2 pounds on the bottom, 1 kilogram on top. So it's going to be 12 divided by 16, which is 0.75, and then divide that by 2.2, which is 0.341 kilograms. So 7 pounds is equal to 3.182 kilograms. 12 ounces is equal to 0.341 kilograms. The book weighs 7 pounds and 12 ounces. So to get the mass, we just need to add these two numbers. So 3.182 plus 0.341. This will give us a total mass of 3.523 kilograms. So that's the mass of the book in this example. Now let's move on to number 4. One box can hold 28 cupcakes, and 5 cups of flour are required to make 3 cupcakes. How many cups of flour are required to make enough cupcakes to fill 12 boxes? So what do we need to do here? Well, let's identify the problem first. We need to convert 12 boxes to the number of cups of flour. So I'm just going to write cups. That's what we're given, 12 boxes. And the question says how many cups of flour are required to make enough cupcakes to fill those 12 boxes. So we got to convert 12 boxes to cupcakes. Now we need to write our conversion factors. We're given the first one. One box can hold 28 cupcakes. So we're going to write one box is equal to 28 cupcakes. And then we have our second conversion factor. 5 cups of flour are required to make 3 cupcakes. So what we're going to do is first, we're going to start with boxes, and then we're going to convert that to cupcakes. And once we have cupcakes, we're going to convert that to cups of flour. So let's begin. Let's start with what we're given. We're given 12 boxes. We're going to put that over 1. And then we're going to convert from boxes to cupcakes. So we need to use this conversion factor. So one box can hold 28 cupcakes. And then for the second step, we need to convert cupcakes to cups of flour using this conversion factor. So I'm going to put 3 cupcakes on the bottom, and then 5 cups of flour on top. So the unit boxes cancels, as well as cupcakes. So now we just got to do the math. It's going to be 12 times 28, which is 336, times 5, which is 1680, divided by 3. So that's 560. So 560 cups of flour are required to make 12 boxes, each with 28 cupcakes. So that's the final answer for this problem. Now let's focus on the metric system. Let's work on example problems using a metric system. Let's say we want to convert 38.6 millimeters to meters. How can we use the metric system to do this? Now this is a one-step problem, but what we need to do is identify what the conversion factor is. So the key word is milli. If you recall, milli is associated with 10 to the minus 3. Therefore, to write the conversion factor, we can say 1 millimeter is equal to 1 times 10 to the minus 3 meters. And this step is important. We covered this earlier in the video. As long as you can write the conversion factor for the metric system, solving these problems won't be too hard. So now we can convert. So we're going to start with 38.6 millimeters over 1. And then we're going to put the unit millimeters on the bottom, and then the unit meters on top. So now we need to multiply. So here we have 38.6 times 1, and then times 10 to the minus 3, which is 38.6 times 10 to the minus 3 meters. Now, we want to put this in proper scientific notation. So what we need to do is we need to move the decimal point 1 unit to the left. We want it to be in front of the first 2 numbers. So this is going to be 3.86, and whenever you move it to the left, this number is going to increase by 1. So it's going to go from -3 to -2. So this right here is the answer. It's 3.86 times 10 to the minus 2. And of course, you could just put this in the calculator. If you type in 38.6 times 1 times 10 to the minus 3, it will give you 0.0386 meters, which is the same as 3.86 times 10 to the minus 2. So hopefully you're familiar with scientific notation. If not, I do have a video on that, which will help you whenever you see things like this. Now, let's work on a 2-step conversion problem using the metric system. So let's say we have 4950 picometers, and we want to convert that to nanometers. Go ahead and work on this problem. So what is the conversion factor for picometers? We know that pico is 10 to the minus 12. So we can say 1 picometer is 1 times 10 to the negative 12 meters. And nano is 10 to the minus 9. So 1 nanometer is 1 times 10 to the minus 9 meters. So those are the 2 conversion factors that we need. So what we're going to do is we're going to start from picometers, we're going to convert it to meters, and then meters to nanometers. So let's begin. Let's start with what we're given. 4950 picometers over 1. And then let's convert that to meters. So let's use this conversion factor. So we have 1 picometer and then 1 times 10 to minus 12 meters. So we can cross out these two units. Now, using the second conversion factor, let's convert meters to nanometers. So we're going to put meters on the bottom and then nanometers on top. So now let's do the math. First, let's see if we can do this mentally. Let's take the 10 to the negative 9 and let's move it to the top. By the way, 1 over x to the minus 3 is the same as x to the positive 3. Whenever you move a variable from the denominator to the numerator, the exponent changes sign. So in this case, it's going to change from negative 9 to positive 9. So what we have is 4950 times 10 to the minus 12 times 10 to the positive 9. Now let's review some rules in algebra, rules associated with exponents. If we multiply x to the 4th by x to the 5th, this is going to be equal to x to the 9th. Whenever you multiply by a common base or two common variables, the exponents should be added. So here the common base is 10, and we're multiplying them. So we're going to add negative 12 and 9, which will give us negative 3. So what we have now is 4950 times 10 to the negative 3. And of course, we have the units nanometers. Now we need to put this in proper scientific notation form. So we're going to move the decimal 3 units to the left. We want the decimal to be between the first two non-zero numbers. So here's some things you want to keep in mind whenever you need to move the decimal and whenever you're adjusting the exponents. If you move the decimal to the left, the exponent on 10 increases. If you move the decimal to the right, the exponent on 10 decreases. So since we moved it 3 units to the left, we're going to add 3 to negative 3. So we're going to get 4.95 times 10 to the 0. And anything raised to the 0 power is 1. So 4.95 times 1 is just 4.95. So this is our final answer. It's simply 4.95 nanometers. And you could type this in your calculator. If you type in 4950 times 1 times 10 to the minus 12 and then divided by 1 times 10 to the minus 9, you're going to get 4.95. So this is the right answer.